Okay, welcome again. I'm going to continue with this to the point series of geometry, uh, taking a look at the Ghpython node, and I'm going to end with kind of that screensaver I've been using for a while, but show how I made a little fun node called a 3D array of points, and had a little fun with the booleans that can swap up the information, whatever you choose to do. You can have a little power over the seed, and you can play with the RGB at different levels, which will play with the different colors, and you can certainly take different steps through it, kind of jump and jitter and make a bunch of different geometries. You've got a pretty fast mesh sphere on here at 6 UMV count, and that's about it. So let's take a look. And I've put it into one of my nodes. So if I move this one over here, you see I've moved it into basically one of my little test nodes over here and installed it. But the way it's made, let's just start from scratch and make it. Let's go in and keep the one above it so we kind of know what we're doing. And what I'm probably going to do is just take this one to preview off and double click this and open the editor and see where we want to go with this. I'm not going to delete the whole import RhinoScript syntax currently because I'm going to be using that. I'm going to just start with the script. Now the general script, I'm going to take it from a text because it's pretty straightforward. However, it didn't have an import random as R. Let's remember that. And I'm also going to import math as M. I may not use math, but let's just start with that. Let's generate 4 lists, empty lists. One called points, and let's get the big G in here for RGB of a list or array for R, G, and let's keep it all cap. Yeah, and B. So those would be the colors that we're kind of playing with in a list and separating the points from one to the other. Staying pretty consistent. I like to keep my script orderly, and anytime I sense something's going wrong, I'll let you know. So I'm going to take it through an iteration for X in range, and we will go from start at 0, even though it doesn't have to be 0, go through 256, but let's call that RGB. And we'll import that, and we want a step as a variable as well. So we're using basically the names of things. And we're going to nest a couple loops in here for Y in range, similarly 0 RGB, and we can have some fun with this mathematically in step. I'll show you exactly what we're doing. I'll show you how you can start playing with this in a kind of Daniel Schiffman processing coding training type way. And then for Z in range, it's a little spontaneous here. I haven't really written this one. I've tried it a couple times and had some success more than others. RGB and step. And like I said, let's just try and keep things neat. So if I'm going to put a space after my commas, let's think about doing that. So now what we have to do in this script is we actually have to think, well, definitely we're going to be bringing in a step, and that will be an integer. And I'm also going to be bringing in an RGB. Let's just put in a few items because I'm going to be needing them. Let's bring in an, instead of a hard-coded 256, let's bring in an RGB that we could actually play off of as an integer from 0 to 256. Let's throw in a seed, because we're going to bring in the seed function. I'm going to show you where I'm going to tuck that seed. And actually, I'm going to type seed in this way, capital S-E-E-D, and I'll show you why. And that's going to be an integer. What I'm going to do with that in this script is I'm actually going to bring in that right away. I'm going to take my random seed, and because that's the method or the function, what's in there, then I can actually make the variable seed so it's distinguished from that. So now I have a seed I can actually play with. And you'll see when I end up bringing, well, I'll bring it in here when I use it. The other things that we're going to get to in a minute, which will be enumerating. And it's a way I could deal with a Boolean. It's kind of strange to deal with a Boolean on a Boolean toggle as an enumerated 0, 1, because you could just deal with it as a Boolean, I guess. But I'm actually going to call these, and I'll show you where we go with this. Enum, what should I call it? Enum 1? Is that what I called it before? I think I called it enum X, and I made that an integer, because it's only going to go from 0 to 1. Yeah, that's what I called it. And then I'm going to have an enum Y. I make that an integer as well. And have an enum Z. And make that an integer. So in doing so, I can kind of just take all these, because I'm going to be using similar ones down here. I'm going to just plug them into the step, the RGB, the integer for the seed, the true, the false, and the true. And these all differ because I'm going to play with the conditionals at the ands and ors when I end up writing this in an if conditional statement. I will have some outs as well, so I'm just going to get ready to put in 3 more outs when I'm ready. Definitely I'm going to be outputting my points, so it can't hurt to to get my points in there because I've already started that list. And I'm going to want my, let's just continue because we're anticipating it, R underscore out. Then we're going to have R, we're going to have G underscore out, and we are going to have B underscore out, B underscore out. And because we've done that and brought them in as outputs, we can always get ahead of ourselves, go down here, leave the scope of that for loop, and consider what we're going to be outputting. And we will be outputting points out that will be equal to the points after we append the list, the empty list of points. We will be making an R out as equal to R, and our G out equal to G, and B out equal to B. So we can get to that point. But let's now we've got everything kind of up and running and ready. I will copy this same format here because I'm using that. You can find this from cut and paste, basically making things kind of work for yourself by custom previews and using the color RGB and then the mesh sphere. You can do this in different ways. I'm going to keep my count the same. And then basically I want to have all my data, this data, copied RGB into here. So I'm just going to do that. RGB. And my UV count is going to be the same, and my base is going to go to the point. So that way I can separate it from the thing that was going on above. And now let's just play with it. We should have something up and running. I'm not sure if it's testing and running yet. Of course, it's missing some things. It's like, well, what do we do with this indented block? We have an indented block. Well, let's do something with it. Within that loop, what initially was done, which was pretty simple, we simply created a point that was equal to the RhinoScript add point function. So add point, let me get it right, point function, and it was set at X, Y, Z. And in doing so, then the points were appended, appending those points to the point that was generated as it ran through those iterations, which was quite a few. So if we're going by, it's going to be quite a few points in that set. And then R would be appended by X. Just this is the simplest way you can kind of do it, just to make sure your script is up and running. Append, we'll set Y. Everything seems to be going to the same, kind of going to the right colors, so that's all right, and darkening and going bold. So everything seems to be working. You can kind of tell by as you get through the script. And if we do that, we run the script, we should have some good power of what's happening. So pull this aside. We've got something. If I leave this on preview off and maybe go here, maybe if I turn these guys on preview on, take that off, I should start to see my colors. There they are. So my colors, that's a pretty simple generation. That's what I was using as my kind of to inspire you to do stuff. Now, how can we change this up and make it a little more interesting? How can we start using those enumerations? Well, what I would do is I would step in after this loop and take everything within this function and start tabbing it in on certain conditionals. So let's say if enum was enum1 was equal to 0, which means false on that Boolean toggle, or let's say if enum2 was equal to 0, or, and I'm just staying fairly consistent with this, enum3 was equal to false, then, and I always think of those colons as being like an if-then statement, like if you're writing a math proof. Let's just tab that in and put that under there. And so if that's the condition, that's what would happen. And it might be nice at this point to go here, back it off to the beginning of the if statement, and just say else do something else, which would be else take all the points and make them, let's just copy it, put it in here and say else make the points only X, only, well, let's do something interesting here. Let's say if that's the case, and these are not set to that, well, let's just run it and see if it tests. What has gone wrong? Enum1 is not defined. Enum1. Because I changed it. Enum, exactly what I did. I did not have enum1. I had enumx, and I'm thinking that way, and I'm Y, capital Y, and capital Z. So you should be able to just get in the practice of debugging, and we should have something interesting to look at. There it is. And if I start to play with these, they're all or. Let's take them all to false. And nothing's changing because I'm actually doing the same thing with both scripts. So it's not doing anything different. So let's do something different. let's say in here, let's use that random function. Let's say random right here. Let's say if we had a random, what was I doing up above? I think it was uniform. So to be an integer, if random uniform was from 0 to x, that's what it's going to do if that's equal, equal, equal. If not, it'll do this. So let's do another test. Pull this down here and say, okay, what happens if that or is the case? There we go. We start to blast it in a direction, make it selective. So if these all go over to, as long as one of them goes to false, it's going to do-si-do to that pattern. So let's take these to true and take this one to false. So now you're controlling geometry by a bit of logic and uniformness. So that was kind of fun, if that's exciting to you. But another thing you can add in here is you can grab this whole section, copy it, and you can do as many of these as you like. Let's back it off and put it in here. But anytime we do that, I'm going to take this one all the way back to the beginning of that if statement. Anytime you're using if again, you're going to, in Python, want to use, not else if, you're going to want to use elif, which is a nice little means. And you can go in here and say, okay, well, what if there was another conditional? Instead of changing these from if enumerate x, y, or z was 1 instead of 0, we could just say this is and. And we could think of this logically as, if all of them happen to be that, let's do something different. And let's take uniform y. Let's say, okay, we're also going to have copy, put this in here, and make it go uniform, selecting things into y. So there's a way that if we test it, and we go down here and we have all of them on true, then it's got to behave like this. But if they all come up false, okay, if they all came in or, but what happens when they all come out? What was the logic I wrote? And 0. If they're all false, then it has to jump in that direction. It looks like it's just staying in that way, so it's not that exciting. Let's do and. Let's take this one to this and let's take this one to and or an and. So and an or an and. And let's see what happens different in that one. So let's just do a little quick test. Pull that one down. Play with these sliders. Put them all to true. And there we go. We've got the 1 working there. Nothing changes there. A little bit changes there with a false and then 2 true. So you're playing with it logically in that way as well. But that's, you can see, having an effect on x and y. And then let's just, for the last sake, and I'm just playing. I mean, you're basically trying to understand logic through geometrical references to it. So I'm going to grab this one. And actually, I'm going to grab all 3 of them and hit copy. I'm going to put them all into here so I can keep my parentheses in order. And then I'm going to basically add one more r.uniform at 0 to z. And remember, we're going to have to add another parentheses to close that off. And let's try that. And that's else any other condition. That's what happens. So let's hit test on that and see. Let's start with all false, which should bring it back to the, okay, but actually, since we changed the logic from or to and, then you can see the effects of having to play here. Change that one to true, change that one true. Now you're going to have an effect on the z. Let's see if we can get the z into works. There we go. So that's the choice, that true, true, true. That's the condition that wasn't met by the first 2, and now you've played with a random function and in the x, y, z. So the else is being chosen. Now, if that's not making sense geometrically to you, you've got to play around with this more. I mean, you could change the script so subtly and beautifully by just having another enumeration, kind of by having your toggles go on and off in these sections as well. And you can add as much as you want and do whatever you want. So I'm just going to leave it there, let it close. It's a fun little tool. If you want to make it a fun little tool, I mean, I obviously have up here, I've gone into the user objects and I've named it this, except I didn't name it right. So let's just show you how I wanted to name it. Let's go into here and call it, we want to call it to the point. Random 3D array of points. Let's just be descriptive. Why not? It's not going to hurt anybody. Let's take that whole thing, copy it, and go up here to create user objects. Let's take that whole thing, copy, which I already did, paste, test, WICKERSON Studios, over here to a icon, and into that warning red, and hit BAMF. And here we go. You've got another one to play with, which was, that's the WICKERSON Studio one. This is the Random Points 2D. That's this one, which is named actually correctly. It should be called WICKERSON Studios GH. It should be called To the Point Random. And at that point, you can just grab all these and plug them back into here, and your script will work as you slowly get everything up and running again. And delete that. Slide that one up and in. And you can always take these to compile, which are much more interesting when you go in here. You just have to clean things up and make sure everything comes in here. I haven't been doing it lately because it just makes for double files, and it's not something that I'm interested in bearing these away so nobody can see what the scripts are. But if you're in here and you actually go into the mode and go into GH, it's going to throw everything in here that you're going to have to take these imports and put them up in the top if they're not being repeated. And you're going to have to double check all of your parameters in your definition. This actually writes a really cool function that runs a main afterwards, runs that whole function, and you can have a nice compiled plugin that nobody can see at your script. But I'm just going to hit cancel on that because that's not what I'm interested in doing. What I am interested in is building a GitHub site, funding through Patreon, that you get access to not only all of these examples, which is what I'm so excited about. I pull all the examples down here. I should probably take these last two and say they're in the example piles here. Examples, 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 examples. And I've just been playing off videos here, drawing from the logic of what I've been doing up here with geometry to the point, the basics, geometry, vectors, lines, and curve attractors. And that's just going to get more and more complex as we get into algorithms and computational studies after we get through meshes and surfaces and breadths and things like that. Anyway, that's the nature of it. I hope you enjoy it. It's a fun little exercise. You start to understand the logic visually and geometrically. I think it's great for designers, artists, architects, furniture designers, jewelers. This is something to really wrap your head around because these nodes cluster so much wonderful, powerful material for you that you can turn into your own custom nodes, which is basically what I've been doing lately. You'll see I've had tons of C practice in C#, tons in Python. Basically looking at different sites to gather information. Actually, I have some time to Unity here from Junichiro Horikawa. Really nice nodes that'll pull this right into a Unity gaming site. And as long as I'm limited to just producing brep surfaces and using Boolean toggles and number sliders, it's just like using Photogram for AR. I can pretty much do anything I want. Let the data drive your forms. Let your work become extremely computational in this form throughout the Ghpython node or C# node. Work parametrically within your Grasshopper script canvas, and then see the magic happen in a CAD forum that all of this is completely printable. And even though it's not colored here, coloring the you could set that over. You can have that actually print over the layers and use a bunch of processes to get back into what you were doing in Rhino. The geometries are simple enough to start. The Grasshopper nodes are becoming more and more familiar to you, and the scripting is becoming, hopefully, on a basic level, taught to you intricately and simply. We will continue with the math library and see where we can go with that, and maybe just a little snippet before we do that. Let's grab this whole thing, cut and paste it since it's working, haul this one down here, take this one to disable. Let's go into the script and see if we can't just mess with this a little bit. And I'm not sure what I'm going to do here, but I'm just going to have a little bit of fun since we're reading the last one. It's going to be uniform. I'm not sure if I can't just, let's throw this through a math.sin y. I'm not sure if that's going to work. And let's do a math.cos. Something's wrong. Math SM. Oh, because I am in this mode and I shouldn't be in this mode. Let's go back to procedural. Let's go back in here. Math.sin, math.cos z. I didn't want to be in the other form. I wanted to import everything in the middle. What happened? Let me go back. Let me just throw my parentheses in there and in there to close it. Let's see what happens when I test it. It's still running. Did something magic happen or not? Just to double check, I'm going to throw an amplifier on here. I'm going to multiply that by a slider. Let's just call it float. And hang on a second. I'm just having fun here. Trust me, having fun. A float, which is going to be set to a float. And we'll grab a nice little 2.00. See what damage we can do to this. And if my math node's working in all sensibility, let's take it to a test and see if this is not having an effect on things. It is not to the mesh. Why is it not? Oh, because that condition is not being met. I need and, or. Let's see if that's going to actually work. So and, or. Let's just get ready. True. There we go. I think I had an effect on it. So maybe. Nope, that's not the pattern. And there it is. I certainly had an effect on it there, but you can see the amplification is not doing enough. So we've got to grab in here and let's grab a massive multiplier, which is a bit ridiculous. It's not too exciting, but we're able to play with those points in a different way. And if that's going to do something snazzy, let's just go back into the script and say, okay, why is it going to hurt if I can't do it in the Y and in the times F and in the uniform direction? So let's just do it in Z and Y and Z and see what happens. And there we go. We've got an effect on it geometrically using a little bit of math and trigonometry, which is a little insane. Like, why would you want to do that? But that's where things start to get extremely complex, because when you go in here and you start playing at any level of wanting to import the math node, you've got incredible functions to pull in here. And I always find it's nice to enumerate through all of these scripts that actually do really well. So you bring in another module library, another library, and you can do magic with it. So it's not complicated too much with that. It's kind of messed up my script, but since I copied and pasted it twice, that's where you end up going and you're playing. And if you're somebody that likes to visualize trigonometry and geometry is your thing, then this is probably exciting for you. I certainly usually don't work trig with such high numbers. I like to really balance things as probabilities and high and low probabilities and see what happens. But either way, it's just jazzed up the script a little bit. That's why I have this section called examples, 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 mainly without explanation, because I don't think it's that important to have the explanation of what's going on here. I'm being playful with some very basic scripts. And the scripts, of course, are up here. I think I probably ended with one of those scripts. 2D array of points. This probably was the math library. Yeah, import here. But we're going to go into it and do a little something with a spiral now and keep going with this. This one is enabling. It's just this nice little spiral that we can make a little more exciting than what's going on there. Let's turn that one off and you'll see what's going on. Anyhow, thanks very much for watching.